Welcome to a lesson with Dr. Powell. Let's take a look at the derivative of x to the x to the x and how to compute it using the boxing rule, the boxing technique. So what we do is we think of splitting up our expression to three separate parts. And what we do is, in turn, we pretend that everything outside of the box is constant. And we take a derivative accordingly and then just add the results together. So for the first box, we pretend that everything outside of it is constant. So this would be like x to a number, like x cubed or something like that. And in that case, we would get simply the constant comes down, and we have one less the constant up there. So for box one, we would have x to the x to the x minus 1, and then we'd multiply by x to the x. Okay, now we move to box, then we're going to add that result to box 2, or to what happens with box 2. So everything outside of box is constant. So in that case, we're going to think like x to the x, all right, where okay, here's our box right there. So this is like a constant, that's like a constant. So what would this be? Well, first of all, we use a chain rule because we think like a constant to a power, kind of like 2 to a power w. How do we take the derivative of that? Well, be like natural log 2 times 2 to the w, but then multiplied by the derivative of w as well. So we'll have to think of it in a couple parts. So here in this case, the constant is x, at least we're pretending it's a constant in this case. So we'd get natural log x times x to that expression. Now we need to multiply by the derivative of this expression, pretending that this x up here is constant and this is the variable. So variable to a constant, that's just like we did over here. So variable to a constant, that would just simply be the constant comes down times x to the x minus 1. Okay, so that was box 2. Now we add to this the result from box 3. All right, where we pretend that where we have the same setup as this, but we just switch it with, so it's x to the x, where this is now the variable. Okay, where everything inside here is variable and everything outside is constant. So in this case, what we'd have is, again, we have this setup like constant to a power, say it w, so it'll have the same start as this last one. So natural log x times x to the x to the x, where x to the x is kind of like the w here. And then, but we have to multiply by the derivative of x to the x, but in the case where this is now what varies, and that's a constant. So constant times variable follows the same pattern. So we'd end up having, see, natural log of x multiplied by x to the x. Because this is the constant. So natural log of that times x to the x, just like we have natural log times that. And the derivative of x is just 1 here. So we end up getting this sum right here. So maybe I should erase this. This is just a little tidbit here. But this result is the derivative. Now you can factor things out, rearrange it however you like. But the derivative of x to the x to the x is as simple as 1, 2, 3. Thanks for watching.